All right, everybody, thanks for joining in again. This would be the determination of the density of our unknown metal by graphing. We have currently, in our previous two videos, determined the mass and the volume of this metal object right here. What I then did was continue to find mass and volume of three other samples of that very same metal. They're all different shapes and sizes. We used all this shot as being one sample, determined its mass, determined its volume. Same for this stripping and the same for this other rod that's a minimally different size and a mass and volume than the original one. I then took that data, and as I was doing the lab, I recorded it in a T-chart of mass and volume. Mass being in grams, and everything below it then would be what I got from the triple beam balance. And then I used that very same sample to find its volume by displacement water. That was my original data on the previous videos. And then these three were the volumes of the object right next to them. I believe this one was the shot, this was the stripping, and this was the other rod. Okay, what I then need to do is take a look at make a pictorial representation of this data. I need to graph it. And from those of you who have been in math classes before, when we're going to make a line graph, and when you make a line graph, you figure out slope. And slope is rise over run. Well, if we plot the mass on the y-axis and the volume on the x-axis, like this, where mass is on the y and volume is on the x, and then draw our line at the end and determine the slope of that, we will get rise over run, mass over volume. So mass divided by volume, which is the concept of density, and that's what our goal is to find out. So the line graph will actually be what the density of whatever that object is. And then knowing the density of that object, I can then, whether I Google it, look on a periodic table, I can prove what the element is that, that I'm trying to determine. So I go back to my original data. And what I need to do now, we call in our science classes our GoBys. What are we going to go by as we number these lines? And a quick count put me at about 40 lines going up the page and a little over 20 lines, almost 30 going across the page. Now, when you measure or graph in science, you always number the lines. Do not number the spaces. And we would need to start this graph at 0, 0. You cannot start this kind of graph at a random number. It's 0, 0 because the least object you could get would be 0. You could actually have none of the metal sample. That'd be the lightest it could be, 0, and it would obviously take up no space, 0. So to determine my GoBys, I have to take a look at what my biggest number is. Well, my biggest number is 64. Now, I do not want 64 necessarily being the highest point on my graph because I always want to extend my graph's numbering past the highest point. So I need to go higher than 64, maybe like 70. 70 would be a good number. Well, and remember when I said there were about 40? Well, I got to figure out a good number to go by if I have about 40 lines. If I go by fives, well, 40 times 5 is 200. That's way too high. That's way higher than 64 or 70. If I count by ones, I only get to about 40. Well, that's not very good either. And there's a simple way of doing it. You take the highest number you want to get to, which I'd want about 70, divide it by the number of lines. Well, 70 divided by 40 is a little less than 2. So I got to go by something a little bit more than that, so 2s. 2s sound like an excellent number to go by. If I count by 2s and I have 40 lines, I'll get to 80. Perfect. Okay? Now, you may certainly write 2, 4, 6, 8, 10 all the way up the page. I am going to, every 5 lines, that'd be 2, 4, 6, 8, and then on 10, I will put 10. So it's understood that this is 2, this is 4, this is 6, this is 8, this is 10. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Remember, we are numbering the lines. 32, 34, 36, 38, 40. 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70. And I can stop there because I know currently my highest number is 64. Now, I guess even if I, 22, 74, 66, 80, even if I went this far, sometimes we do something in science called extrapolating, where we use the graph to figure out a higher number than what we have. So it's not bad to go a little higher than that. That would be fine. Now I want to determine what to go by on my volume. Okay, well, again, I had a little more than 20 lines. and I only have to get to, well, a little higher than 7. Let's say I want to go to 10. Well, if I number by ones, I'm only going to use about half this graph. And 0.7s, 0.8s, those are all kind of weird to go by. 0.1s would be nice to go by, except if I go by 0.1s, I am never going to get to 7. That'd take 70 lines, so 0.1s is bad. Again, if I numbered by ones, I'd only use up by half the graph. So using 0.5s, we'll put 10 a little ways over here. So I think 0.5 sound like a very good number to go by. Remember, this is 0, so this is 0.5, this would be 1. 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10. And that's plenty far. In fact, I only had to go to basically to 7. So even this one, I could have numbered by something smaller, but if I would have gone by something smaller, 0.1s is probably the next logical thing to go by, and I just didn't have enough room. So that by default, 0.5s were my best to go by. Okay. In the next video, we will talk about plotting the points and making our best fit line.